All right, everybody. So I'm Lovee Jain. I am a software engineer at Prezzee, a Women Techmaker ambassador, and also a GDG Melbourne organizer. And tonight I'll be talking about BFFs could be your new best friends forever. So as Anki mentioned, BFFs are all your backends for frontends. So I have a question for you guys. How many of you have heard about backends for frontends or have already worked on them? Cool, quite a few. Well, if you don't know that, I'll make sure you know about it by the end of the talk. All right. So before I start, I'd like to share a story. I'm not share that. All right. So as you saw in the video, there used to be very simpler times when there was just one front end served by a backend. Nice, easy. But then as technology grew, so did a lot of devices. And there are now more channels and more devices that need a backend. And they're all still sharing the same backend, making those backends more like a monolith. Now, over the years, many companies have been trying to break apart this monolith into multiple microservices. But the problem remains the same. These front ends, these devices, and user experiences, they have their own different needs. But getting the data from generic backend services then it needs to be processed and manipulated at these front end levels. So, solution, BFFs. So now what we do is we introduce a thin layer between your front ends and your backends. Again, it's a thin layer and there is no logic in there, so that this thin layer actually acts as a backend per front end. So for each user experience, you might be able to create a custom backend, and that would be your BFF. Now, I need to reiterate on this that there is no logic in there. It's a very thin layer. So earlier, when your front end was calling your backend for multiple things, this time it's just going to call your backend for front end, and the rest of the things would be done by that BFF. Okay. Another thing I would like to mention is that if you have a very good microservice architecture, you might not need a BFF. It is mainly to prolong the life of your monolith. All right. Now, let's get on to some benefits of a BFF. It is easier to maintain. Given it's a very thin layer, it could be independently managed, independently scaled, and can be worked on. Talking about maintenance, because it is like a custom backend for a particular front end, it makes more sense for that front end team to actually also maintain their own BFF. So what it helps with is they have the autonomy on what's going on to their front end. Next would be resilient to API changes. Now, for example, you decide that you want to have a different response coming from your APIs, but your front end is not ready to consume that response. Having a BFF layer in between would allow you to actually manipulate and process the change that is coming from the API so that your front end can still use it. And then you can go for graceful degradation. Another thing is, if your APIs are not working, say there is a downtime there, you can actually cache some results in your BFF and use those for your front end. And hence, there wouldn't be any downtime for your front end. Another one would be better error handling. Now, obviously, with generic APIs, there would be a lot of errors. So your front end might not process all kinds of errors. having a layer in between would allow you to actually read those errors properly and actually give more meaningful responses to your customers, making it much more better error handling. Now, while I'm listing all these benefits here, I'd like to mention a quick caveat that your mileage may vary. My experiences at Prezzee, while working and investigating on a BFF, have been pretty positive. The reason being that you may ask, okay, Lovee, you're actually adding a layer in between. That means there would be some latency. Now, for that, I'm going to ask you another question. How much data is your front end processing and how much is it retrieving? There needs to be a balancing act between the two. Now, let me give you a very good example. We at Prezzee sell gift cards, right? So if you want to buy a gift card, you would place an order. So what your front end would do is call your backend. It would create a draft order. It might create a payment intent. You may use third-party providers such as Stripe or something else. And then a payment would be completed, it would be accepted, your order would be fulfilled, and then finally, when the order is complete, you would send that, okay, order is successful. So there might be a lot of to and fro going on from your front end and your back end. Now, with a BFF layer in between, what would happen is you would just call your BFF once, and rest of the calls would be handled by your BFF layer to your backend. And when the order is successful, it can give the response. A lot more cleaner. Now, what you can further do is you can deploy this BFF closer to your backend. That means either in the same availability zone or in the same machine, and hence you will have shorter response times. The other thing you can do is you can actually cache some results. So another example from Prezzee, we sell gift cards, so we have like a wall of cards, like the gift cards that we sell, and that doesn't get refreshed very often. So we can cache those results, and then we just serve it from the cache. We don't even have to make a network call to your backend. So that's where you can actually balance your latency things. Another one would be code duplication. You may argue that, okay, there are different front ends, but there still needs to be processing done, and there might be some duplicate data, duplication happening. I would say that if you have more targeted code there, not really. The other thing could be that even if it is a bit of duplication, aren't you ending up decoupling your front end from your back end, giving you more flexibility to scale? Okay, now let's move on to some example problem. So at Prezzee, we have the scenario. We used to have normal Prezzee classic website served by a monolith, good, nice, easy. But then we grew. Now your Prezzee classic became your consumer web. We also have mobile apps. We have Prezzee business, which is for businesses to buy gift cards and say they want to buy in bulk and then give it to their employees or staff. And then we have Prezzee resellers, which is businesses who would like to use our APIs to sell gift cards on their platforms. So it's more like a B2B2C. Now, with each of these front ends, they have very different needs. For example, mobile apps, they actually support push notifications, geolocation data, there's video uploads and stuff, which consumer web may not actually. So there is also Prezzee business. Prezzee business is more about placing orders, and they have a proper portal where they can place orders, look at invoices and stuff. With Prezzee resellers, it's all about APIs, so we don't really have a UI for it. Now, obviously, these are different channels. They have different needs. And at Prezzee, we have been actively moving away from a monolithic architecture to a microservice architecture. But as I said, the problem is still not solved. So what do we come to at is a proposed solution. This is the version 1.0, where we actually serve the consumer web via Web BFF, Android via Android BFF, iOS by iOS BFF, and then Prezzee business and Prezzee resellers by business BFF. And slowly we get rid of the monolith. you may say that, okay, we have created a lot of BFFs here, but how many BFFs is the right number of BFFs? So it actually depends on a few things such as feature parity, organization structure, or product roadmap, etc. So one good example is, say you have very different teams working on Android and iOS. You may have different code bases, you have different release cycles. So it may make sense to have an Android BFF and an iOS BFF. But at Prezzee, we have similar code bases. There's not much difference in the two. And sorry, similar features. There is not much difference in the two. So there is a feature parity. The same team works on them. And then it makes more sense for us to probably have one same mobile BFF serving both Android and iOS. Another example could be with the business BFF. Now, as I mentioned, Prezzee Business has a dedicated front end, which businesses can use to check invoices and stuff. But Prezzee resellers, they're all about APIs and don't really have a front end. There is also a difference in the mode of payments. There are two very different teams working on it. The product roadmaps looks very different. So it makes sense to actually divide it into two different BFFs, giving us version 2.0 of our proposed solution. Okay, now I'd like to also mention how BFFs work with micro front-end architecture. Before I do that, I'd like to ask how many of you have worked on MFEs or have heard of them? Yeah, micro front-end architecture. Yeah, sorry. I should be. Okay, so micro front-end architectures are gaining a lot of popularity because they allow you to decompose your front-end into multiple smaller micro front-end apps, which could be semi-independently managed and can work loosely together in one single front-end. So at Prezzee, we have Prezzee Business, which is a front-end with two micro front-ends. One of them is Prezzee Business Portal, and the other one is Prezzee Business Campaigns. Now, there are two very different teams working on them. Portal is more about placing orders, creating invoices and stuff. Campaigns is more about promotions, discounts, and other things. So it makes more sense to actually divide this business BFF into two, so that your business portal is served by a business BFF and managed by the business team, and your campaigns portal is served by campaigns BFF managed by the campaigns team. Now, what we have done here is we have got one slice of app managed by one team. We have gone vertical, which is a very good architecture considered to be. All right, so I've been just posting about why BFFs are good and why to choose one. So obviously, if your front ends have specialized needs, it makes sense. There's also performance optimization, team autonomy, and you can even implement fine-grained security measures, such as hiding any sensitive information, which would reduce the risk of exposing any critical information to your unintended clients. Now, why not to choose a BFF? Obviously, this comes with developmental complexity. It needs its own developers, its own resources, and hence there is an increased infrastructure and maintenance costs. So if you are doing a small project, you might be better off with a monolith. Monoliths are not that bad. There's also an issue with API synchronization. While you're creating so many BFFs, the structure might change and then you might not be able to sync all of them. So does that mean that BFFs could be actually your enemies? Well, it depends. And if you feel like that, then you might try GraphQL, API gateways, or just another microservice. All right. Now, does my current architecture have to be changed? No, because as I mentioned, BFF is like a thin layer that you can just add in. And if your method contracts are the same, you may just need to make some minimal changes there, and it would work. It would work like a Lego piece in between. Finally, why should we invest hard-earned money and precious time in this? Now, as I mentioned, you may actually end up increasing the life of your monolith. So if you are still trying to move away from your monolith to a microservice architecture, you might get more time. It might help you increasing the life of it. Also, if you know that very soon your systems might start failing, databases might cause errors and may not be able to handle the scalability, you might add in this layer and it would do the bandwidth fix for some time. So are you ready to befriend a BFF? Okay, any questions? Yes.
Yeah. You said your Prezzee comes from a monolith architecture, right?
Yeah.
So, and then you transition to use this BFF thingy.
Yeah.
And you say that this BFF version of the Prezzee is 1.0.
Yeah.
So, how do you guys, your team, make sure it's like this BFF layers is not gonna messing up your existing microservice that you have before? So
okay,
you say that it's adding to your thin layer.
Yes.
Yes, and that means that some of these usage of your codes might change pi by pi and different focus there. So thinner and other aspect and
Yeah.
So
So it is like a thin layer, which means it is an independent application that you can just add. Like there is no business logic, so there's not going to be much changes. Whatever your backend was doing, it would still do the same, but directly talking to your front end, instead of directly talking to your front end, it is now going to talk to your BFF layer, and then this BFF layer would talk to front end. So you don't have to make changes anywhere in a way, if you look at it. You just do more processing here.
Yeah. Question about that. So I've worked with backend in the past. So let's say you have a notification service, payment service, and inventory service. What the BFF layer would do is call all those three services for you, and you'll just make one API call, right?
Yeah.
So it's just basically like doing a call command on your behalf, and you're just reducing your API calls that you ideally would want to do.
Yes, in a way.
So so if I just create an endpoint on my backend itself, which would do it for me, and I would call those three services rather than not using a BFF layer. What if I do it directly? What's the con of that one over using a BFF layer?
So BFF is mainly to serve your front ends and not your back ends.
Yes. No,
so if you have a, okay, I'll give you another example. So I'm in the resellers team, and there's also Prezzee business. And if you're placing an order, it's basically the same process, but in a different way, and they have different needs. So, for example, if you want to look any order details, which say not relevant to your API customers, they're just relevant for the business customers, and the API is giving you out everything after order completion or something like that, then you'll have to do processing at business layer. You'll have to do processing at the APIs. So instead of doing that, and this is just one thing. Yeah. There could be other APIs, other things. You will be doing that in the BFF layer, so that you don't have to do that in the business bit. Yeah. And it's easier and cleaner architecture.
Is it like casing some reusable, like repeatable things that usually are called by the consumer, like front end and web, or basically like that, or it's like caching layer? Because the call is like you make a separate specified, like Karthik said, you make a specific specified thing for your BFF to uh, to handle these like don't directly use to the monolithic things, but add a thin layer to populate, not changing your business logic, right?
Yeah,
so,
don't change your business logic. No.
Pretty similar like caching, right?
Not really.
Not really caching, but
it is a part of it.
Part of it.
But it does more than that.
Yeah, I see.
Yeah. Any other question?
So is this approach can be used this in any language of backend programming?
Yeah. So we actually have a BFF in TypeScript, and you guys are working on, I think, Goa? Kotlin, yeah.
Oh.
Yeah. Yeah. So we.
Kml?
Yeah. So these guys are mobile team. Just to be clear.
I think this is a concept. The language doesn't matter.
Doesn't really matter. Yeah. Any other questions? Yes.
I was very curious about your when you talk about caching.
Yes.
When we look at it, actually, it was like there were both ways. Like you can have caching at the front of the BFF with CloudFront.
Yes.
But also you can have like packing memory caching.
Yes.
You have used for both, which is. Would you recommend the any of that situation? What would you?
Yeah, it would depend on the situation.
So I'm interested in knowing the effort for BFF. So assuming your backend team is 10 people, how many people do you need for BFF?
I'll actually I'd like to reframe your question because BFF is for frontend, right? So your frontend people should be doing your BFF stuff, ideally, but not necessarily, because your frontend people know what they want from the backend.
That is what I used to do in my first job. So they had backend services ready, and whatever extra data mobile needed, so I just used to combine multiple services. So this is actually adding. I'm not sure if these guys add an actual server instance or something. I just used to use their own packages and extend it to mine, kind of. So, yeah.
I had a slide. I did not mention it because I'm not a GCP expert, but you can actually deploy it as a container or yeah. You can either deploy it as a container, as a Lambda function. Obviously it would add latency, so you'll have to think through. So you can do anything if you like.
I'm not that great with that.
Any
other questions?
Yes. Question as well. Is it necessary, like if you have like multiple BFFs and they, is it necessary they should be consist like all REST API, or like if mobile would like to use something more mobile specific?
I think it really depends on how you would like to use it. Yeah, that's the whole point, right?
Yeah, that's the point.
Yes.
Let me check my understanding. For example, if there is a get user REST API for admin console, I don't want to trim any secure data, but for general mobile apps client, we want to trim secure data. Is it BFF the thing?
I'm not sure if I understand your use case correctly. If you meant at admin side, would it be like a front end or is it your backend?
So what he's saying is an app so any website might have an admin section, right?
Okay.
So in that admin section, then you might not trim like the user's card number or something like that. So for example, if you are in with Medibank or something, then the user might ask you for your card number.
Yes.
The admin would be able to see it, but the user has that data trimmed. So that is is that a BFF use case is what he's asking.
I'm not very sure, to be honest.
I see.
Yeah, I'm not sure.
It could be.
It could be.
It depends on how you put the architecture out. Like in the same way that Prezzee here has a resellers API or BFF and consumer or mobile one. You might have an admin BFF for the admin interface that talks to the admin, talks to the backend services. Because generally an application like this, your backend services, they're all considered well, they might be considered to have the same security or data access, and they'll be talking to each other or to other systems with full data visibility. Whereas the presentation to the front ends will differ, right? So you might have an admin BFF, which is talking to the same services that the consumer BFF is, but they'll be returning different data. They're not, but I would argue generally you want your entitlements layer or the system which protects the user data for privacy and security to be outside of the BFF and not part of the BFF.
I see. Thank you. Thank you. Thank you.
Any other questions? Well, if not, thank you so much. And I'd like to especially thank Women Tech Makers team who actually helped me with the travel support so that I could actually be here amongst with you. So thank you all.